Okay, we're gonna do geometric sequences, and so I feel like I've taught this lesson over and over again. It's the same thing, but anyway, a geometric sequence is a sequence whose recursion formula is u of n plus 1 equals u of n plus r times r. And the idea is we've gone over this, with arithmetic you add or subtract to get to the next term. With geometric, you're multiplying or dividing to get to the next term. And this is known as the common ratio. And I'm just angry because I know that you've sat through this lesson before. So you've sat through me, I give you, here's the example, 2, 4, 8, 16. You know by inspection, Mr. Adler, you're multiplying by 2. Or the fancy ways, 4 divided by 2 is 2, 8 divided by 4 is 2, 16 divided by 8 equals 2, so the R is 2. You've sat through this before. Same thing, I can give you another example, 1, 3, 9, 27. You say, Mr. Adler, you're multiplying by 3. The fancy way, 3 divided by 1 is 3, 9 divided by 3 is 3, 27 divided by 9 is 3. The common ratio is 3. Next example, we're 555.5. Mr. Adler, it was not so clear, so we can use the fancy way. 50 divided by 500 is 1/10. 5 divided by 50 is 1/10. 0.5 divided by 5 is 1/10. So the common ratio is 1/10. And then the second to last example, 469, you're not really sure? Take out your calculator. 6 divided by 4 is 1.5. 9 divided by 6 is 1.5. 13.5 divided by 9 is 1.5. Your common ratio is 1.5. And this last example I made up, no, I know what it is. Once again, maybe you don't recognize it, but you know they say geometric sequence. So you're going to do the fancy way, negative 160 over 400. Your calculator should say negative 2/5. 64 divided by negative 160, your calculator should say negative 2/5. So the common ratio is negative 2/5 or negative 0.4. Okay, so we got the recursion. The next thing we want to talk about is the general formula. We know from past lessons, the general formula is, can you see me over here? Let me move the calculator, move the computer over here. We know the general formula is u of n is equal to the first term times the common ratio to n minus 1. And you've done these problems before. You've done these problems before. How can I write it? Well, you have it right here. So for this one, the common term u of n is equal to 2 times 2 to the n minus 1, right? We know for this one, u of n equals 1 times 3 times n minus 1. We know for this one, u of n is equal to 500 times 1/10 to the n minus 1, and so on and so forth. This is 4 times 1.5 to the n minus 1. And the last example is u of n is equal to 400 times negative 2/5 to the n minus 1. And so in your studies over the years, we know the questions that are coming. So we know the questions that are coming. You're going to see it. So for example, if the first term is 3, let me erase this. So you know what's coming. You've done these examples before. So if I say, you have a geometric sequence, and the first term is 5, and the common ratio is 3, they'll say, find the sixth term. And you say, okay, the sixth term is equal to 5 times 3 to the 6th minus 1, which is 5 times 243, which is 5, bring up the 1, bring up the 2, 12, 15. What's another example? The sixth term, the seventh term is 128, right? And the common ratio is 2. Find the first term. So you might say, okay, 128 is equal to the first term times 2 times 7 minus 1. 128 is equal to u1 times 2 to the 6th, which is 64. So u1 equals 2. And this all comes down to using the formula to find the term. So you'll get some examples using the formula, and I want you to try it. I just want to look at a couple of other things. Just little things. If I say, I say the fourth term of a geometric sequence, blah, blah, blah. I'm going to stop there for a second. What is the fourth term of a geometric sequence? Well, what's the first term? Well, the first term is u, right? What's the second term? The second term is u times r. So if someone says the fourth term of a geometric sequence is, immediately you're going to say, oh, you know what? The fourth term is u times r to the third. What's the ninth term of a geometric sequence? You say, okay, stop. The ninth term is u times r to the eighth, right? Little thing. Now, we know from the formula, my metaphor is like these jumps. So if I say you're starting at the first desk and you're going to the fifth desk, you would say, okay, there's 4 jumps, 5 minus 1. Or I might say you're starting at the first desk and going to the 9th desk. How many jumps are there? You say, okay, 1 to 9 is 8 jumps, 9 minus 1. So I want you to think about it. How many jumps are there from u of 3 to u of 8? Right? And so the answer is, 3 to 8, that's 5 jumps. How about u of 2 to u of 11? And that's 11 jumps. Right? And so when you work on these problems, I want you to think about this. I want you to connect these two ideas. So, if you're told that in a geometric sequence, hold on a second. If you're told in geometry, the fifth term is 48, and the second term is 12, find the common ratio. Okay, so when you see this kind of problems, in the second you see fifth term, you go, okay, u times r to the 4 is 48. Second term, it's also u times r, which is 12. And then, that's the starting point. What are you going to do? Well, let me tell you. This is a nifty little trick. Just divide them. U r to the 4th divided by u r is equal to r squared, which is equal to 48 over 12, which is 4. R equals plus or minus 2. So what I want you, That's going to be helpful for the homework. Last little trick that I want you to do. So when they say this, here's another thing. They say that A, B, C are terms in a geometric sequence. Well, I don't know what's coming after it, but once again, when you see it structured like this, you say, okay, therefore B over A is equal to C over B. And I want you to use this for the homework. Once again, you've had this lesson before. I want to see what you can do. I want you to do the Cambridge homework. I want you to do, I will put the problems that I want you to do. And yeah, that's it. Okay.